Hello, and the last time that we met, we looked at solving systems using elimination, but they were problems where you could easily either add the two equations together and get one variable to drop out, or all you had to do was multiply one equation by -1 and one variable to drop out. As you can see today, that is not the case. So our first step is going to be to multiply one equation to equal the other coefficient so it will eliminate. In this case here, I see that this x, we could easily take this whole equation, and if we multiply it by -3, that will give me a -3x, which will nicely drop out with this term. So I'm going to go ahead and rewrite this then. I still have 3x minus 5y equal to -2. And now I'm going to take this -3 and I'm going to distribute it, I'm going to distribute it to all the terms that are in that equation, which means that my new equation will be -3x. -3 times +3 is -9y, equal to -3 times 4, which is -12. So when I go and add these two together, 3x plus -3x drops out. And then we have -5y plus -9y, which is -14y. And -2 plus -12, which is -14. Then I can go ahead and divide this on both sides by -14. Giving me y is equal to +1. I'm then going to take this and put it back. I'm going to go into the equation I didn't mess anything with. And that gives me 3x minus 5 times y, which is 1, equal to -2. That gives me 3x minus 5 equal to -2. Add 5. Which gives me 3x equal to 3, so -2 plus 5 is 3. Divide on both sides by 3, giving me x is equal to 1, which means that my ordered pair solution is 1, 1. So to summarize, before we go ahead and not talk about the check, we're solving by elimination like we did yesterday, and finally we're checking it. If we verbally check this, go back into this first equation. 3 times 1 is 3. 5 times 1 is 5. 3 minus 5 does in fact equal -2. And then x equals 1. So then 3 times 1 is 1. 1 plus 3 does in fact equal 4. So we know that this is a valid solution. Moving on to example B. I see here that this first equation, if I simply multiply this one by -2, I will get a -2x, and it will cause this 2x to drop out. So when I rewrite this, I distribute this through, and I get -2x plus 6y equals -2, because -2 times x is -2x, -2 times -3y is +6y, and 1 times -2 is -2. And then I have 2x plus 2y equal to 10 for my second equation. -2 plus 2 cancels out. 6y plus 2y is 8y. And -2 plus 10 is 8. Go ahead and divide both sides by 8, which gives me y is equal to 1. I know a lot of you are probably noticing that a lot of our answers are 1. This is merely coincidence. I didn't plan it originally to be that way when I picked these equations. Now I'm going to take this and put it into the second equation, since it's the one I didn't mess with yet. And then I have 2x plus 2y, and y is 1. Put that in, equal to 10. 2 times 1 is 2, so I have 2x plus 2 equal to 10. Subtract 2 for both sides, giving me 2x equals 8. Divide both sides by 2. giving me x is equal to 4, which means my ordered pair solution is 4, 1. And if I quickly check that in my original equations, 3 times 1 is 3, 4 minus 3 is in fact 1, 2 times 4 is 8, 2 times 1 is 2, 8 plus 2 does in fact equal 10.